Welcome everyone. Thank you for joining today's expert webinar. My name is Nizam from SpringPeople. SpringPeople is India's biggest enterprise technology training provider. As a part of our expert webinar series, we are glad to have today Joydeep Bhattacharjee, the principal engineer from Nineleaps, who's involved in developing analytical and machine learning solutions for various customers across different industries. He has also authored a book on fast text, which is a popular natural language processing software. Today, Joydeep will demystify ways to build AI products that get easily adopted. Now, if you have any questions during the presentation, please type in your queries in the questions box. And at the end of the session, Joydeep will answer them. Also, I request all of you to share your feedback after the session, which will help us to maintain the quality of our upcoming webinars. Now, without any further ado, I welcome Joydeep Bhattacharjee to kindly take over the session. Over to you, Joydeep.
Thanks, Nizam. Let me just share my screen. Right. So, hello everyone. Thank you all for joining in this webinar. I hope everyone is doing great. It gives me a great pleasure to present this webinar. So, let's get it started. Today, I'm going to present demystifying ways to build AI products that gets adopted. Why I believe this topic is important? Because whenever we as developers, we as product managers, we as bringer of ideas, think of various ways or various solutions of making the lives of people around us better. But if we just have an idea, it is not enough. We need to bring it to the world in such a way so that our target users, the people whose problems we are going to solve, actually are able to use the product and the solution and are able to improve their life. Want to write a story. It may be a great story, but you need to write the story in such a way that the book cover should be good, the print should be good, the book should be readable. So similarly, there are industry-wide best practices to create AI products so that it is more usable for the users and it gets adopted quickly. So these are the topics that we are going to touch it to make our AI products better. We need to map the user needs. We need to understand how to map user needs to the product success. We need to understand how to do better data collection and evaluation. We need to do correct management of user mental models. We need to give good explainability. So generally what happens is, so moving on, the core aspect of any AI product is of course creating the machine learning model. And this is my favorite machine learning definition, which is machine learning is a field of study that gives computers the capability to learn without being explicitly programmed. So what it is probably possible if you take any machine learning model or any machine learning solution, it is probably possible to explicitly program all the rules that there are. If it's a cat image and you want to identify if it's a cat image or a dog image, you can probably check each and every uh, uh, each and every pixel and then predict if it's a cat image or not. But that probably would not be feasible. It would be prohibitively costly. So machine learning is the application, or rather, in the bringing in machine learning in your product brings in that capabilities to make it in less cost. But what by itself machine learning or just writing a machine learning model or a machine learning prediction is not enough. You need to have a whole context surrounding it. You need to understand where the data comes from. You need to understand, have a good data gathering process. Data is kind of one of the very important aspects of your model. Uh, okay, is it possible to fix the screen? The entire screen content is not visible. I would try to make it as visible as possible. Thank you for letting me know. Okay, so basically you need to have a good data gathering model. You need to have the correct ML infrastructure around it. You need to have a good team surrounding yourself. or your product so that it is able to build world-class ML infrastructure and create the right predictive model. You need to give only just creating the model and making predictions is not enough. You need to give or you need to surround your model around a good business context so it is able to generate the right amount of business context surrounding your model. And finally, you need to see if the users whom you're trying to solve the problems for are actually getting value out of the product. So starting out, let's see some of the good rules of thumbs when creating AI products. Every AI product with respect to a business context will have some good rules of thumbs. For example, if the aim of the exercise or if the aim of the product is to create a medical analytics application or a medical analytics product, it is probably not right to give dangerous cancer treatment advice or dangerous medical treatment advice. So such kind of rules of thumbs are important in any context. Specifically to AI, AI needs very good R&D investment. What is good for teams and organizations is also true for countries as well. If you take a look at China, China has invested in the recent years, China has invested a lot in AI research. That is why currently China and the US are almost similar in terms of AI capabilities. They have almost the same number of papers coming out and the same amount of revolutionary tech coming out of these two countries. So even though it has traditionally been the US who has invested in AI, because China has disproportionately invested more in AI in the recent years, it has kind of caught up to the amount of tech that is coming out of the country. This is the same is true for teams and products and organizations as well. Second is you cannot, if you're creating an AI product, you cannot operate in a tech bubble. You cannot just focus on the tech. For example, if you're trying to create a juicer, this is an actual example where if you create a very tech heavy juicer with a lot of intelligence baked into it, but still if it costs prohibitively high, the users are not going to buy the product. Then what is going to be the value of your product? Hence, it has to be understood if the users are actually going to or will be able to use the product. Whenever you guys are going to build an AI product, whenever the team or the org is going to build an AI product, it has to come with a clear vision of what the product needs to do. I have seen a lot of teams just build POCs after POCs and the struggle to find valuable problems for the analytics team to solve. And they fail to invest in building the right skills. As a result, they fail to get traction with their AI pilots. The AI analytics teams they had assembled wasn't working on the right problems and wasn't able to use the latest tools and techniques. I had worked with such teams, and the last I heard from them, they were still just burning VC money by claiming to be an AI product. Another thing that I like industry-wise is different companies have or rather focus on building or improving their core area of focus, and whatever is not important, they outsource. For example, Apple outsources its store management. Other companies such as Google and all also outsource many of their core businesses. Hence, if something is not areas of focus, it is probably better to outsource it. The advantage is that the developers that you have will be focused on the correct AI needs of the organization. Just one second. Next, as a business, you cannot be complacent. If you have found success with your AI product, probably it's better to not be too comfortable with your current success and keep on improving your product. Keep on finding ways in which you can bring more value to the users. Otherwise, it would be soon before another company or another team comes up with a more revolutionary product, and then your product would just go down in the market. Another thing that should be considered is time to market. I like this example, but even though some say that Google Home is probably better than Amazon Echo, because Google Home was around 2 years late than Amazon Echo, Echo still has around two-thirds of the market share. Next is um, when building AI products, you have to assume that customers are not like developers. Generally, as developers, as product owners, we are very intimate with the products and we understand the ins and outs of the products. That kind of gives us tunnel vision. What developers generally assume, or whenever developers interact with the software, they assume that it is like a tool. But when users and customers interact with the software and AI products is generally taken up as an experience. That has to come into the picture when designing an AI application. Of course, out of these all, this is my favorite, banking on AI hype. Many companies, even though they do not actually use AI, claim to be AI startups just to bank on the hype. So when creating AI applications, there is a lot of confusion. Like if my current problem, if I can bring in AI to the current problem, or is my current problem not, you can say, AI solution friendly. In the market, it has been seen that possible AI applications are things such as content recommendation. For example, Netflix recommending new movies, prediction of future prices. Many companies have internal applications where they see where the market trends are going. Improving user experience. Natural language processing, trying to make sense of what the user types in. Recognition of entire class of products such as facial recognition. Low occurrence events such as fraud, something that probably happens once in, let's say, 1 million. Showing dynamic content such as Facebook. Uh, Possible non-AI applications are where you want predictability. You want static content. Something such as a banking app, you don't want to see different numbers on your banking app when you log in 2 different times. That is okay on a site such as Facebook. In fact, Facebook sites such as Facebook are based upon such kind where 2 times if you log in, you would see two contents. But if you go to a banking application, you don't want to see 2 different numbers on the site. When you're sending money, let's say to your friend, you don't want any error to happen. So if minimizing costly errors is a concern, AI should not be implemented. You want complete transparency in the process. Maybe you applied for an Aadhaar card or a PAN card. You want to know what is happening in the background. You want complete transparency in the product. If if you're trying to build such a kind of application, maybe AI is not the right choice. High speed of development. Building AI needs high speed of development. You would probably need 6 months to come up to 80% accuracy and 6 more months to come up to 85% accuracy. If you need to build a product, if you need to build an MVP and you need to bring it to the market fast, AI is probably not the right choice. Maybe later. People value current processes. Maybe again, the political spectrum, or let's say you are building a kind of a financial process where people actually value the current processes. Maybe AI is not the right choice. So how to understand if I should actually bring in AI, or let's say I want to work in an AI on an AI problem. What should I do? There are various ways we can define AI problems. One is, of course, we need to understand who are the users. We need to get what their values are, which problem are like we should target for solving. We need to understand what is the solution that we are going to implement for that problem. And of course, we cannot go forever. So we need to understand when is the experience done. An example of this is basically the House of Cards. So when Netflix was coming up with the House of Cards series, they looked at data from The hugely popular show House of UK show House of Cards. The picture here is from the UK show House of Cards, and they also looked at preference for films of David Fincher and people who liked Kevin Spacey films, and they found that a significant percentage of the subscribers were likely to watch such a House of Cards show. Hence, Netflix commissioned 2 seasons of the series at a total cost of 100 million. So something like this, where the decisions are based on data, is probably something where you can bring in AI. For our case, let's uh, 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 let's think about trying to create a simple AI product where, let's say, our end users are farmers, and we are creating a product where we'll build a disease predicting application. This is a picture of a disease that gets into brinjal, and the name of the disease is phomopsis blight. So how to understand if our users, how to match the users with the user problem to the AI problem. So we need to understand, we need to take a real problem and see if the AI solution, if bringing an AI solution actually gives unique value to it. Maybe we can study what are the competitors that are already in the market in that solution space and see what they are doing. What are the things they have tried? Will building a specific kind of AI solution bring in a different value proposition to the users? AI solutions generally can be categorized into automation task or augmentation task. Automation tasks are generally fixed processes which you can which you can easily take out and bring in an automatable task. Generally, automation tasks are dangerous and difficult, and there is a need to scale. An important thing for automation task is that there needs to be a correct version of things. For example, automation is highly present in the automobile market. If let's say the Maruti is going to build an Alto, there is a specific car that is called an Alto. So there is a specific version of things. Augmentation is where tasks are probably pleasant and carry social capital. Something like being an artist, creating art. There is no correct version of art or correct. There is no correct version of art. Sometimes some people, for the same art, some people call it beautiful, some people call it ugly. And then there is the reward function. So generally, when creating products, people give the direct value that is coming out of the product, but only focusing on the short-term effects or the direct effects is not enough. People should always focus, or developers and product managers of the product should always focus on the long-term effects, the second-degree effects and the third-degree effects of the products as well. I'm sure if Facebook had focused on the second degree and third degree effects, one of the core rallies against Facebook is that they create connections, but those connections are not strong. People don't feel happy. They just see others happy and they just feel that everyone else is happy except me. So if Facebook had contemplated the second degree and third degree effects of its products, it would have been in a far better place right now. How to decide if the AI solution that you are bringing is actually giving unique value? There are of course various ways to do that. You of course have to decide on the target user first. You can then go and ask the target users if the solution, what is the actual problem that they are feeling, and if the solution that you are bringing in will actually help them. Deciding on a solution, maybe you can have 2-3 solutions in your disposable, so that you can ask the users which solution is bringing the greatest value to them. Another way of understanding, sometimes users are not able to understand from before if a specific solution will actually bring value to them or not. So a way to counter this is through the Wizard of Oz test. uh, Wizard of Oz test is interesting, where you don't actually build the product. For example, so you don't actually build the product, but you have someone in the background, some expert in the background, working like the AI product. For example, in a disease predicting app, Let's say the farmer post, you have like a dummy app. The farmer posts or a normal user, maybe a small subsection of users, post the picture, and there is a real expert in the backend thinking that, okay, is it a disease brinjal or a disease vegetable or not a disease vegetable? Uh, this is called the Wizard of Oz. There is an interesting reason why this is called a Wizard of Oz, and I'll highly recommend you guys to read the story. Deciding if the rule-based solution also might work better. What if, let's say, you have a financial application and you want to see if someone who has applied for a loan actually clarifies or qualifies for a loan. Someone who has no income, it is, in fact, you don't need an AI application to understand that someone who has no income should not be, will probably not have the resources to give the loan, and hence his loan application should not be accepted. You don't need an AI solution for that. Apart from that, there is, of course, bringing the complexity into the picture. Bringing AI into any application is highly complex, and you have to determine if the value that is coming from bringing in AI into the application is disproportionately high than the cost. Uh, always remember that bringing in complexity, or rather AI complexity, brings in additional 9 dimensions to the whole complexity of your application. You have modularity. What are the different applications in your product? You have the states that needs to be there in the product, different states. How far your intelligent agent can plan? What is the different uncertainty? The preference of your AI model. What is the different number of agents or intelligent agents working with each other in the whole system? How will the AI system learn? And what are the computational limits? If your prediction takes 5 minutes and you need results in 1 minute, then it is not going to be useful. You need to get the best prediction within your 1 minute time frame. And of course, lastly, interaction between the previous 8 dimensions. A little bit of word on the difference between automation and augmentation products. Automation are good when it is when the work is predictable and probably dangerous. Uh, Creating augmentation products generally is more difficult because what happens is that if you just create, if let's say I'm a painter, I will not appreciate an AI product creating paintings for me. That is why AI produced artwork has a lot of backlash in the market. But maybe an easy way to counter this, this makes it very difficult for AI product managers to think of specific ways in which they can bring value. Things can be done is going to the user and asking which is the lowest value task that they will be willing to delegate, or what are the areas in which they will be willing to give it to someone new. So, or maybe something like you can ask a question like, tell me more about the action that the user did during the day and how often they they took those actions. So taking those questions and building AI products, keeping in mind the user, would probably help the developers and the product managers to create the AI product that brings more value to the users. Some another way of thinking about it is that, what if the augmentation product that you are trying to develop has been seen as a dead end industry wide? For example, although clothes are basically a lot of machinery is used in the clothes, all of the clothes that we wear are created by a person, because the dexterity of the human hand cannot be matched by any machine. Hence, we just get to wear cheap clothes because they are created by low cost laborers in India and Bangladesh. Uh, then you need to think about what is the reward function that is coming into the AI application. Because it's an AI application, it is not going to be perfect in 100% of the cases. There are, of course, ideally, true positive and true negative cases should be high. If you're creating a disease predicting app, if the plant has the disease and it is predicting the disease, or if the plant does not have the disease and it is predicting that it does not have the disease, is of course ideal. But because it's an AI product, that will not happen all the time. So, for example, if the plant does not have the disease, you need to take into account the false positives and the false negative cases. If the plant does not have the disease, and what would happen if the AI application predicts that it has the disease, and vice versa. If the plant does not have the disease, or rather, if the plant has the disease and the app predicts that it does not have the disease, you need to take into account scenarios where these kinds of things happen, because they will happen. Maybe one way to do it is you have a different, when the confidence is low, you have a different button where you go and ask for expert help. So an interesting part of this is that you can't do both the things at the same time. Maybe you'll think that I'll increase the true positives and the true negative cases, but generally uh, it's a balance, or rather, seeing if false positives are more or false negatives are more. It's a balance. So you would need to optimize for either precision or recall. For example, if basically, for example, in our disease predicting app, maybe it is okay that if the plant does not have the disease and the app predicts that it has the disease, in those cases, probably it's okay. The greatest thing would be that the farmer goes and sprinkles some medicine. But what would happen if the plant has the disease, but the app predicts that the plant does not have the disease? That is not acceptable in those cases. So probably you would need to optimize your application for recall. A great example of optimizing for precision is, you must have seen in the news lately that there are a lot of non-performing loans, or many businesses have not been able to give loans back to the banks. Basically, if the bank had a more stringent vetting mechanism, and if they had not accepted, or if they had a low rate of false positives, acceptance of false positives, basically here you are trying to predict if the loan that is being given to the user, or the applicant, is going to, if he or she is going to default on the loan. So then you would not have missed any of the false positives. But the disadvantage is that you would need to miss out on some true positives as well. Maybe they just got greedy. One way of optimizing for precision and recall is a concept called as friction, where what you do is, for example, in it would depend upon the context. An example of this is Google. For example, Google tries to understand if the bot is, or rather, if the search, the person, the user who is doing the search is a bot or not. In those cases, it would probably give some kind of images and say that, okay, click on the images that are cars, or click on the images that are mountains, and so on. Something like this is called the friction. Of course, you would need to keep into mind that there is always the risk of customer churn if you bring in too much friction. So you need to see how much friction you would want to bring into your whole process. Uh, of course, once you have decided how you want the product to be, what is it that you want to do, there is the developers come into the picture, that they load the data, clean the data, do some feature engineering. For example, if it's a normal, what are the colors, or rather, in facial recognition or other kinds of computer vision application, the ML model needs to understand what are the colors in the application. So we understand violet, but the computer is not going to know that. So that use an RGB scale with within a spectrum of numbers between 0 and 255. So changing an actual vague quantity into real numbers is called feature engineering essentially. Then you have the train test split. Basically, the idea is that giving the idea, let's say you are a teacher and you want to understand if your students have actually understood your product. So ideally what you would want to do is during the test, you do not want to give any of the questions that you have already taught in the class. Otherwise, the students might just have memorized the respective questions, and then just that would not give sufficient signal about whether the students have actually understood the material or not. So what you do is you have your total data set, and then you divide your data set into training and testing data. You train the model on the training data and then see the model, how good the model is on your test data by passing it on the test data. Then there is the model deployment and inference, which again are a whole new beast in its own class. That is how the developers see the whole workflow. But what you, as the designer of the application, need to understand is that once the model goes to production, you have to understand if the users are actually getting value out of it or not. The ways to do it is by having very minute monitoring mechanisms in place to see if which are the places of the for the features that have been implemented. If the features that are there are actually being used by the model, if a feature is meant to be used a lot by the users, but they are not used that much, that is a red flag. Or let's say maybe a lot of people are downloading the app but never using it. Then maybe the communication from the marketing side has not been done. Or there are other ways to see places where so each and every aspect of your application should be marked and should be monitored and tracked to see if they're actually performing for the users. Then there is, of course, the data collection. Once the app goes, or rather the machine learning models have been built, during that phase also you need to understand what are the data collection mechanisms that are being taken into account. Okay. So thanks for letting me know if my mic is shaking. If there are any other problems, to let me know as well. So one of the ways, just let me fix it a little bit. Okay. So how to understand if the data collection that we are doing is correct or not? An ideal way would be to have good documentation on the types of data that we are trying to collect. Maybe such kind of a format as given here would help it to work. For example, you can have something like who is the user, what do the users need, what is the user action that is recommended once the AI application gives a prediction, what is going to be the model system output, what is going to be the how will the ML system learn, what is the different types of data that is required, what are the key levels in the data. So for example, in our disease pricing app, our users are the farmers who need, so their problems is to identify disease crops. Then the user action maybe would be to spray medicine on the crops. The location and picture of the different disease crops are what is given out by the ML model. The ML system learning would happen by seeing changes in the crop systems for disease markers. The data required would be running the plant pictures and then get the weather information, the geography, the time of the year. Different diseases happen in different times of the year. So that way we can get the different kinds of data. The key levels that would be seen are the farmer's acceptance or rejections of the app, suggestions, medicine application time, see what is the user generated feedback, what is how the harvesting information has come, whether the application or rather whether the AI product has actually helped in making the farmers more productive. So such kind of documentation when designing how your data collection would happen would help a great deal in understanding if the data that you are collecting are correct or not, or are rather helping the product or not. Of course, during the data collection process, privacy and security are of utmost importance. Uh, if local laws and legal requirements are not kept in mind, a huge headache might come down later during the whole process or during creating the AI product. For example, Google had to shell out 750 pounds for each iPhone user because Google was illegally snooping data. This may be okay. So this total amount around total to around, I think, around $3 or $4 billion. That may be okay for Google because Google has deep pockets, but it may not be okay for your team and your organization. So how you're getting data should always be treated with care. Next is, of course, giving users the option to delete their data. Although many product managers may think that giving this option would, or rather fearful of giving this option to the users, such kind of options always bring greatest trust or greater trust in the eyes of the user, and at the end of the day, will bring in more users to the whole system. Even if then even if the users are okay with sharing or give you the so yeah, I was saying that giving the users, so now you can go ahead and check, or rather, if you're using your friend's mobile, you can go to the incognito mode of Google Maps and create or rather search there. So the data would not be saved there. Such kind of practices uh, are always encouraged by the users and bring more trust towards the company, towards the organization, and towards the application. So in our product, maybe something like on the left, your neighbor Paul also reported plants with diseases. This is probably not the right, because you have inadvertently said that the neighbor Paul also has the diseases. If Paul gets to know of it, in during the start, Paul would probably might have consented. So, hello, am I audible? I just got not very audible. Am I audible to the listeners?
Yeah.
Yes.
Yes.
Okay. So if you, even if Paul would have accepted that you can share his name to other users, once Paul gets to know that his neighbor knows that he also, his plans also have the disease, he might get offended and just log out of the whole system and not use the system in the first place. So you should be very careful, even if you have the right to use users information. You should be very careful about what information and what can be the downstream effects of using such information. So maybe something on the right is better, where you give some other farmers in the area also reported similar diseases, to if you need to give better confidence to the users. Other aspects of data collection is that overfitting and underfitting. If you're targeting a more global audience, then just focusing on, when during the training, just focusing on Indian audience or the US audience is probably not right. You need to keep into account fairness and bias, trusting of the product. Sourcing the data responsibility is very important, as we have just discussed. Limiting ambiguity in the whole process. You should be very clear about what is going into you should be very clear about how the whole process is happening, and so that there is less ambiguity would just bring in more trust towards the product. Of course, model tuning and maintenance needs to be done all the time. As soon as the model goes into production, it is outdated, it is trained on old data, and hence when regular model tuning and maintenance needs to be done so that the ML model is relevant and continually gives good value to the users. I'm getting some feedback that my voice is probably not audible. Do let me know if it breaks. Okay, let me just reiterate it again. So AI products change with time. So what would happen is that because the output would be changing, you would need to constantly set user expectation to what the AI products can and cannot do. AI products cannot be the solver of everything. Maybe some users would think that because this is AI, it would solve everything. That is also a recipe of disaster. On the other hand, many people would not be very trustful of the AI application. That is also not correct. So setting correct expectation is very important. Ways to do this is that understand what the user is trying to do, speaking more and more with the users, what mental models they might have regarding the product. Maybe there are competitors in the market. You need to understand what mental models they already have regarding other products. If let's say yeah, in our disease predicting app, if there are other disease predicting apps in the market, and if they have a system of taking input from other sources such as cameras in the farm, then you would also need to understand that users would also expect you to have the same capabilities in the system as well. Maybe it has not been possible to integrate that capability yet, but that should be communicated effectively to the users. What is the step-by-step process that novice users might be using to accomplish the task? Maybe something like for first-time users, connecting to farm cameras should be there, while for the next time the user logs in, this is not required anymore. How uniform is the process between different users? Depending upon geography, different users may have different expectations from the product. So user onboarding uh, can be done in stages, or rather the correct way of giving what is the uh, right communication to be done. An example of this might be that, for example, on the left, welcome to this best farming assistant app. This app uses sophisticated deep neural net machine learning to make your farm processes smarter, because we believe that AI should be in everything. That is probably not the right, because the user is not interested that you are using deep neural net or some other tech inside your product in the backend. The user is interested in what is the value the product can give him. So a better communication might be a farming assistant app to help you assist in your farming, to help you improve your yearly output. So that kind of communication brings focus on the value that is received by the user, which would help make or bring back more trust to the product. User onboarding, of course, for new users, user onboarding should be done in stages. The right introduction should be there, similar to what we discussed here. Explaining the value, not the technology. Only introducing new features when needed. Bombarding the users with the whole plethora of users may not be the right way and would just overwhelm the users. This would help in bigger user churn. And designing for experimentation. One big factor between a normal software product and an AI product is that AI products change. Hence, to make the user comfortable with the product, the design should be such that users see what are the full range of output that the AI product can give. It should be encouraged and it should be readily available. That way, users will be able to be familiar with the product and would will be more than happy to go through the learning curve. And a way, or rather a template to start with the users might be that this is your give the product name, in our case farming assistant app, and it will help you then saying what are the benefits of the product that the user will get. So it will help you identify disease crops and thus increase your farming yield. uh, at the start, you can say something like it might take some time to improve, but you basically are saying this to set the stage of letting the users know what the users can do to make the AI app better. So you can help it get better by connecting it to your farm cameras. So you are asking the users to also help the app to get better at what it is already doing. It is important to understand that along with the AI app, the users are also learning. So it's both the AI app is learning from user behavior and the user is learning from the AI behavior. So different ways of managing is that through feedback with personalization. We'll talk about implicit and explicit feedback in just a moment. Failures are an interesting way of handling how users can be taught and how the co-learning can be done in a better way. Reminding, reinforcing, and adjusting, because AI products will change with time. So it is always important to keep reminding the users what is needed from the users, how best to use the product, and what is the specific way in which the AI product will be able to give maximum value to the users. Of course, with changing user behavior, the AI app should also be sufficiently adjusting. So an interesting aspect for this is, for example, we could not, so for example, in the left side, the AI app was not able to understand what the disease was. So we could not understand what this is. But if you just dismiss it, that is probably not the right approach. A better approach may be on the right, where we could not understand this. Then you have buttons where you either ask for expert help or tell us what this is. So you are basically mm, positioning the app to understand from the user behavior, or to get valuable information from the user behavior, which will only help in making the app better. So if you have such kind of opportunities in your application context, do not miss out on such opportunities. Mm, So these kinds of measures are basically to increase the trust that the users have. Other ways of do that is that whenever explaining the data sources should always be clear. Recommendations only, the predictions or the recommendations that are being brought in should not only stop it at that, it should always be followed with the actual user action, accounting for situational stakes. For example, the what happens when false positives or false negatives actually happened. So explaining data source or data source explanation can be done either in a specific manner or in a general manner. So for example, the brinjal probably has phomopsis blight as the fruit has rotten areas. Chances of this spreading to higher other plants are high. The disease predicts with 80% confidence. So this is an example where you are giving specific information about why the application thinks that the plant in this case is diseased. Uh, on the other hand, there is a general way of giving information where you say that you are thinking that the application thinks that the plant is diseased because the app uses plant pictures and location information to identify probable diseases, which is on the right. So it nothing. So either of these two, it is not like general is better than specific or specific is better than general. What the explanation or the communication mode that you need to adopt would depend upon the type of users that basically would depend upon the type of users that you are trying to service, and hence you would find what kind of language works best for you from extensive user testing. So whenever you are giving communication or whenever you are on each and every aspect that the application is communicating with the user, there should always be optimization for understanding of the users. So clarifying the key elements. So neither bombarding the users with too much information, neither keeping into or neither keeping out or hiding information is optimal. The key elements should always be clarified. Explaining all the outputs and deciding on the amount of confidence that should be given to the users. Explaining the data sources, something like this, where you kind of explain where the data source is coming. Model confidence displays and data visualizations. Maybe this is applicable if the users that you are going for has a technical bent. If the users, maybe in those cases, data visualizations or complicated data visualizations make sense. If the users are not of a technical bent, maybe less complicated data visualizations would make more sense. So what is the specific communication? So each and every layer of communication should be thought out very carefully. So another way of doing model confidence display is maybe you give the n best output. So you say that there are three possible likely diseases. You say that either it has form of light or fruit rot, or the plant is probably fine. This would this type of information is important because, or rather, is should be thought out important whether you want to give the users that the application is not sure about what is present in the output, or you want the application to be more confident about its output. Of course, it is always better that the application is, if the application is confident, but the application turns out to be wrong and the user knows it, that would just bring down the trust ratings of the application. So these kinds of communication should be thought out very carefully. Maybe you can have a button where you ask for expert help. That can be ways of circumventing such issues. Feedback and model improvement. Ways of model improvement are that you go ahead with either explicit or implicit feedback. And based on those feedbacks, you continually do model tuning so that your AI model becomes better and better. Explicit feedback means that you explicitly ask the users for specific feedback. Common ways of doing that is using a star-based system, or you ask the users to write some feedback from the different experiences that they have. Implicit feedback is something like, an example of implicit feedback is, let's say I gave some wrong spelling in Google when searching for something in Google, but the Google understands that it is probably a wrong spelling and shows results for the right spelling. So showing results for the Dark Knight, it thinks that I'm probably searching for the movie Dark Knight and gives the results for that. What if I was actually searching for Dark Knight, which is the second one? If I click on the second link, it would tell Google that actually when the assumption that it had made, or the prediction that it had made, that I was searching for the movie was wrong. And that is an example of, I did not explicitly tell Google, but Google was able to understand it from my actions. So that is an example of implicit feedback. All explicit, the point to consider is that all possible areas or all possible options for both explicit and implicit feedback should be captured thoroughly, and there should be provisions. Of course, explicit feedback might always come out as a friction. Not many people are always ready, or rather, people are always more ready to give negative feedback than positive feedback. So not always all explicit feedback might be helpful, or rather willing. So as much implicit feedback as possible from the data should be gathered. Mm, of course, depending upon the different kinds of application, your balancing control and automation should be thought out very carefully. An example of control is, let's say you have an AI, or rather Uber application, and you give the users the application to, or rather the advantage of giving, or rather in our, for example, in our disease predicting app, you say that, okay, the application is predicting that it has formoxis blight, but the user thinks that it does not have formoxis blight and gives feedback in a different way. So that is an example where you give the user to give, or you give control to the user. So every control request is a form of feedback. So here, for example, in this similar case, you give the user the control to click on the second link and then see the results from that respect. So every control request is a form of feedback and should be utilized to make the application better. Allowing for opting out. So basically, something like if you have seen in Uber, that you can get out of the system. So all or rather such kind of allowing the users to opt out of the system would just bring in greater trust towards the system. Providing more editability. So for example, in Google, you can go to the settings option, and there in your search history, you can edit the search history, and Google would not show you results from that search history anymore. So giving such kind of options to the users would just bring in greater trust towards uh, towards the application from the users. Take for example this option of editability. If I had searched for something, let's say I was searching, so I'm sure many of us are totally irritated. Like in Amazon, you search maybe for something, some furniture, some piece of furniture, or some book. And even if you had bought the book, it repeatedly shows you products of the same material, which people get irritated a lot. But if Amazon, I'm not sure if Amazon has that option, but if Amazon had that option where you can go and change your search history, and it tells you that, okay, we'll not be using your search and give recommendations to you, it would just make the user experience better. Defining errors. Errors are a great way to make your AI application better. Of course, you need to understand where the source errors are coming in. User errors may be user system or context errors. Maybe the user is just trying to do the wrong thing. In our disease predicting app, maybe it is just trying to search for, it is taking pictures of, let's say, animals. The AI app is not going to predict diseases in animals. In this case, the user is just wrong to submit pictures of animals. Maybe it is the age-old system errors where the software is broken for some time, or there is an outage. Maybe contextually it is wrong. Of course, accounting for timing in the user journey is important. For example, if in our disease predicting app, during the start, if the application does not give correct diseases, the user would be forgiving. But if, let's say, I am the farmer, and even if down 1 year down the line, I'm still seeing wrong predictions from the app, I would just think that the app is broken and stop using the app. Weighing situational stakes and the error risk for each kind of error is important. So what are the different kinds of errors? There are prediction and training data errors. So there are mislabeling errors where a lot of training data that you get is mislabeled. For example, in this news article that I saw recently, was that a lot of fish was mislabeled. So let's say you are, if your AI product deals with fishes, it will have a lot of bad data. And this is another simple example. All these pictures are labeled cats, but interestingly, there is a frog in this picture as well. See if you can find it. Not much time, we'll move ahead. Training errors, misrepresentation in your training errors. So things such as the axis is not perfectly, is not correctly scaled, or the axis is, one of the axis is not there. So such kind of misrepresentation in your data errors will be costly during the training process as well. Then you have, of course, the learner's errors. An example of learner error is, let's say, you have a natural language AI application which is trained on English data, and you want to train it on Chinese data. It would probably not generalize to Chinese language as well. So underlying assumptions that the machine learning model makes should be carefully considered for the data that it is going to train in order to avoid learner's errors. So, and then you have the input errors where the users may just give wrong input. What if the output that comes out of the system are not of use for the users? The user will just lose trust in the whole system. Of course, there is the inherent software systems and failures and technical errors. What if there is an outage in any part of the system? How will it affect the users? Those things should be planned carefully as well. One error that I missed out was boundary errors. Where is the kind of error? So for example, in our disease prediction app, what if the brinjal was of weird shape which the AI model was had not encountered? Uh, uh, Maybe the brinjal is perfectly fine, but it is just in a weird shape. So that kind of puts it in the boundary phase where the AI is not able to understand where it is disease or not disease. Such kind of things should be carefully considered. Failures. Failures, we have talked about errors, and then there are failures in different parts of the application. But failures are not the dead end by itself. Failures, if effectively managed, can be a boon to the whole system as well. So failures can be managed using effective feedback, returning control to the user, and always assuming malicious intent. Maybe it is not a failure at all, or rather, what if the failure is due to malicious intent from the different users? Feedback, we have talked about explicit and implicit feedback. So getting feedback from different users and understanding what the user wants would go a long way in making the application better. Mm, Returning control to the user. For example, in our Uber application, what if I am, so what happens in Uber, you might have seen, or even in Ola, you would have seen that if you're in a large application, it gives you the option to take the pin to the nearest road where you take the cab from. So such kind of giving control to the user would make it easier for the user to use the application. And it is also an effective way to get feedback from the users and understand where the users generally board and deboard from. Of course, if you don't of course, don't if you don't take into account, always assume that your users are going to have malicious intent. A very famous example is where you have the K-bot that became racist because many people were feeding it racist or having conversation with it in a racist way. So you have to always assume that your product will be used in a not ideal way, or rather may have malicious intent from the users. Um, Now that you have an understanding of what best to or what are the different dimensions that you need to look for when creating AI products, you can go ahead and start creating the product. But the first thing that people think about are the tools. The good thing is that there are a lot of tools. There are cloud tools, there are open source tools that are there to cater to different AI needs. But the real challenges when deploying AI workloads are actually in data volume and quality, advanced data management, and the skills gap. And that is where the primary focus should be when creating, or rather working on and designing an AI product. Access to high degrees of compute power, algorithmic bias, and concern for job loss are not general challenges, although I believe that algorithmic bias, privacy, and ethical concerns should also be high in this whole scenario. Now that we understand what are the different aspects that we need to take into account when creating an AI product, how do I start? And an important thing that I want to say is that whenever creating a product, basically you are creating a product because you think that the existing system has some defects. But we need to understand that we only have a few things. People are comfortable with the existing system, and hence it is very important for us to consider that what are the different ways in which people will be willing to change. We only have a few weirdness points to spend, and we should be very careful of what things that we want to change. uh, clean up Cleaning up and setting up good baseline practices will save us a lot of headache. Maybe starting small, maybe starting from a rule-based solution is the right approach. That way we can start small, see if the idea that we have is actually worth it, and build it up from there. Of course, data. Collecting as much data as possible and keep collecting data is important. collecting as much data as possible and keeping it in store. We should never throw. One of the biggest no-nos of data science is that no matter how much data we have, we should never throw away the data. Patience and evidence-based growth. We should have patience regarding our AI products. AI needs time to make it itself better. So we should have patience to see if the AI that we are building actually has the potential. So thanks everyone. This has been a webinar. I hope the information that I've presented here will actually help you create great AI products. That's it from my side. Thanks everyone for joining. It has been a great pleasure to present this webinar. It is 4:10 right now. We have around 20 minutes for the questions. I'll be taking questions from now. Okay, I have a couple of questions here. So ML is not suitable in the agile framework. I have mixed feelings around the whole agile. Sometimes I think it's so the way I see it is that apart as far as the present popular paradigms are there, agile is kind of proved itself to be the best paradigm till date, and we the more we use it, maybe the more we understand what are the limitations of the current paradigm, and maybe we can come up with a better paradigm. uh, what are the industries AI can be implemented? So the question is, what are the industries AI can be implemented? So I have, just one second. So I have showed some of the possible places in which people have seen or different products have kind of been able to be successful when looking at AI products. But these, I do not believe that these are the only cases that are possible. Content recommendation, prediction of future prices, improving user experience, natural language processing, finding anti-class, low occurrence events, and showing dynamic content. These are shown to hold promise when deploying AI products. Of course, these are not the only system, and I would say a good way of finding if the AI is uh, actually has unique value or not is by doing field research, getting or having a very clear idea of who the target user is, and then doing field research on the users or maybe a subset of users as much as possible. I would say that having kind of a Wizard of Oz test where we kind of have a dummy application and have an actual AI, or rather an actual human expert in the backend seeing the input from the users and giving the predictions should also work. Uh, the advantage is that we do not need to, of having the Wizard of Oz test, is that you do not need to actually create the product, but would get a sense of if the product, will the product be accepted by the user, or if the is the product creating value for the users. So doing such kind of tests, doing such kinds of surveys are good ways to understand if I can implement AI in this problem space. Okay, one other question is coming. AI still has to, so Parvela asks, AI still has to rely on feedback and other ways of data. How can this be handled to make better decisions? So this is something that I have, or rather, explained in detail. So the best way, according to me, is getting feedback, both implicit and explicit. Get as much explicit feedback as possible from the users. Get as much implicit as possible from the users. So let me go to the slide. So these are examples of explicit feedback. These are examples of implicit feedback. So depending upon your context, on your business context, both explicit and implicit feedback, even control request is a form of feedback. So depending upon your business context, both explicit and implicit feedback should be leveraged as much as possible, and they should ideally uh, automatically feed into the whole training system so that mm, the model is continually trained and continually made better so that it is able to bring more value to the users. Uh, Achutan asks what kind of steps we should take to improve creation of ML reports. Uh, this is great. This is a good question in the sense that by ML reports, what are the different monitoring systems in place? The first thing that needs to be taken into account, what are the different monitoring systems that are in place to help gather as much data as possible? So getting different kinds of feedbacks from the users, uh, or getting how much the application is being utilized, what is the user churn, as much data as possible should be captured, how much each feature is being utilized. If the feature usage is increasing as or there is a good correlation between increasing number of users and increasing a specific feature utilization, then it's a good thing to say that the feature has been successful and the ML application and the ML process training process is bringing value to the user. If there is less correlation between a feature usage and user growth, then probably it is not a good. So such kind of reports should be gathered from the system so that and should be monitored regularly and carefully to understand if the AI model and the feature that we have built is actually helping the user. If something is not helping the user, then it is totally okay to kill off that feature and redirect the focus of the development team towards a better feature that can bring more value to the users. Uh, So Atul asked, what are the languages which we can work on AI? So I would say that even though Python right now is the most popular in terms of languages, I don't believe that you need to use only Python. You can, I would say, depending upon the team languages that the team, because ML algorithms are already, or rather popular ML algorithms are already well documented in the systems, in different systems. Of course, if you probably want to use TensorFlow or PyTorch, then probably you would need to go with Python. But even then, you can have a separate system where you would go through the whole training and deployment process. So depending upon what the team is already comfortable with and what are the algorithms that you want to work in, you can go ahead with the language of your choice. Okay. Uh, Parvela, at times AI may go wrong and it could be a disaster for some industry. How to handle such a situation? So I specifically don't have, once the disaster happens, uh, I don't have a specific way of, you can say maybe I've not seen such a situation. Maybe I can have you guys better might know about such a situation. But my recommendation in such cases is prevention is better than cure. So if, let's say, disaster happens, according to me, disaster happens mainly because of privacy and security issues, or uh, let's say the correct rather the correct AI application has not brought into the picture. For example, uh, your AI or your application might have required static content, but still you went ahead and brought in dynamic content with an AI application, and you thought that AI application would be better in such cases. Maybe the best way would be to see what the users and understand what the users actually want, and then uh, try to gather, or rather and try to implement the solution based on that. Maybe fall back to a rule-based solution in such cases. For example, my favorite example is with non-performing loans. If the banks had not given non-performing loans, or rather, if the false positive cases and the precision was high, especially when the loan amount was huge, they might have survived the present crisis. So, such kind of preventive measures, I believe, are better to take into account so that AI do not go wrong at the offset. Okay, so Atul asked commonly used programming language. So yeah, as I had said, it is Python currently, but you don't need to limit yourself to that alone. Okay, we still have around 5 minutes. We can take up questions. Okay, then. I think that's it. Thanks, everyone. Again, it has been a great pleasure of mine to present this webinar. If you have any additional questions, you can always reach out to me. You can get my LinkedIn link from the webinar link. And again, thanks for joining. It has been great presenting to you all. Thank you.
Thank you, Joydeep, for the insightful session. And thank you all for joining today's expert webinar. Kindly share your valuable feedback, which will help us to maintain the quality of our upcoming webinars. And also, you can also find the recording of the webinar, which will be uploaded on Spring People website very soon. Thank you all and good evening.